Exploring the Red Planet, 20 Years of Mars Rovers and Their Impact on Space Exploration.
Introduction.
The exploration of Mars has captivated human imagination for decades, and a significant chapter in this story began with the advent of robotic rovers. Over the past 20 years, NASA's Mars rovers have transformed our understanding of the Red Planet, confirming the presence of liquid water, uncovering complex geological histories, and inspiring a new generation of scientists. This report delves into the journey of Mars rovers, starting from Sojourner's pioneering mission to the latest advancements brought by Perseverance, highlighting their discoveries, technological evolution, and lasting impact on space exploration.
The pioneering era, Sojourner 1997. The journey commenced on July 4, 1997, when Sojourner, the first successful Mars rover, landed on the Martian surface. Developed under NASA's Mars Pathfinder mission, Sojourner was a compact,
microwave oven-sized rover equipped with basic scientific instruments. Its primary mission was to demonstrate that a rover could function on Mars, and it achieved this by analyzing the chemical composition of Martian rocks and soil.
Sojourner's mission lasted nearly 3 months, far exceeding its initial 1-week lifespan. It managed to analyze 15 rocks and transmit valuable data back to Earth, laying the groundwork for future rovers.
The success of Sojourner proved that mobile robotic exploration was not only possible but also essential for understanding Mars.
The Twin Titans, Spirit and Opportunity 2004. Following the success of Sojourner, NASA launched 2 twin rovers, Spirit and Opportunity, which landed on Mars in January 2004.
Initially designed for a 90-day mission, both rovers exceeded expectations, with Opportunity operating for nearly 15 years until its demise in 2018.
Key discoveries. 1. Spirit.
Spirit landed in Gusev crater and discovered evidence of ancient hot springs and minerals altered by water, indicating a wetter past on Mars. It operated until 2010, ultimately getting stuck in soft soil.
2. Opportunity.
Opportunity landed in Meridiani Planum and quickly found the first definitive evidence of liquid water in the form of hematite blueberry spherical mineral formations that formed in acidic water. It traveled nearly 30 miles 45 kilometers across the Martian surface, setting the record for the longest distance driven by any rover on another planet. Together, Spirit and Opportunity revolutionized our understanding of Mars, confirming the presence of liquid water in its history and reshaping planetary science.
The next generation, Curiosity 2012.
On August 6, 2012, NASA's Curiosity rover landed at Gale Crater,
marking a new era of Mars exploration.
Curiosity was significantly larger and more advanced than its predecessors, equipped with a suite of scientific instruments to analyze the Martian environment.
Key achievements.
Curiosity discovered evidence of ancient riverbeds and the chemical ingredients necessary for life, indicating that Mars could have supported microbial life billions of years ago. It utilized a unique landing method called the sky crane, allowing for a safe descent to the Martian surface. Curiosity continued to explore Mars, providing insights into its climate and geology while searching for signs of past life.
Building on success, Perseverance 2021. Launched in July 2020, Perseverance landed in Zhurong crater on February 18.
2021, this rover carries forward the legacy of its predecessors by focusing on astrobiology and collecting samples for a future return mission.
Notable features.
Perseverance is designed to collect rock cores and store them for potential retrieval by future missions. It operates alongside Ingenuity, the first helicopter to fly on another planet, which has completed numerous successful flights, demonstrating the feasibility of aerial exploration. Perseverance aims to find signs of ancient life in Zhurong crater, which is believed to have once contained a lake.
Technological evolution of Mars rovers. The evolution of Mars rovers reflects advancements in technology and engineering.
From Sojourner's limited capabilities to Perseverance's sophisticated systems, each rover has introduced innovations that enhance exploration.
1. Mobility and autonomy. Sojourner was tethered to its lander for communication, while later rovers like Spirit and Opportunity could traverse significant distances. Curiosity and Perseverance exhibit advanced autonomy, allowing them to navigate and make decisions independently. 2. Scientific instruments. Each rover has been equipped with increasingly sophisticated scientific tools enabling detailed analysis of the Martian environment. Curiosity's onboard laboratories and Perseverance's sample collection system exemplify this technological progression. Impact on science and education. The Mars rover missions have had a profound impact on scientific research and education. They have not only advanced our understanding of Mars but have also inspired a new generation of scientists and engineers. Outreach programs, initiatives like Rover Goes to Mars engaged students worldwide, allowing them to participate in missions and cultivate interest in planetary science. Many program participants such as Abigail Freeman and Courtney Dressing have pursued successful careers in space exploration. Inspiring future generations, the discoveries made by Mars rovers have sparked interest in STEM fields, encouraging students to explore careers in science, technology, engineering, and mathematics. Comparative insights from sources. While various sources emphasize different aspects of Mars rover missions, they collectively highlight the scientific breakthroughs achieved. The first source primarily celebrates the achievements of Spirit and Opportunity, detailing their contributions to Mars science. The second source provides a broader view of Mars rover history, including international missions like China's Zhurong rover. The third source emphasizes the educational impact of the Rover Goes to Mars program and personal stories of those inspired by these missions. Timeline of Mars rover missions. 1997, Sojourner lands on Mars, marking the first rover exploration. 2004, Spirit January 3 and Opportunity January 24 land, providing evidence of past water presence. 2012, Curiosity lands, discovering ancient riverbeds and organic compounds. 2021, Perseverance lands, focusing on sample collection for future return missions. Conclusion. The exploration of Mars through rovers has not only expanded our scientific knowledge but has also inspired a global audience. The legacies of Sojourner, Spirit, Opportunity, Curiosity, and Perseverance illustrate human ingenuity and the enduring quest to understand our neighboring planet. As we look to the future, the advancements made in Mars exploration will pave the way for new discoveries and possibly even human exploration of the red planet. Through continued innovation and outreach, we can ensure that the quest for knowledge about Mars will inspire generations to come. Counterintuitive information in the content. 1. Longevity versus expectations. The Mars rovers, particularly Spirit and Opportunity, were designed to last only 90 days. However, both exceeded their life expectancies dramatically, with Opportunity operating for nearly 15 years. This challenges the typical narrative in engineering and space exploration that emphasizes the importance of tightly controlled project timelines and expectations. Instead, the unexpected longevity of these rovers suggests that robust engineering might yield far more than anticipated. 2. Limited mobility to extensive exploration. The initial rover Sojourner was limited in its mobility and required constant communication with its lander. Comparatively, later rovers like Opportunity and Curiosity were designed for mobility and autonomous navigation. The counterintuitive aspect here is that the first rover, which was less capable, still managed to conduct meaningful science, whereas the more advanced rovers were initially designed to conduct expansive exploration but faced significant challenges and glitches that limited their capabilities. This suggests that sometimes simplicity in design can yield critical scientific contributions, while complexity can introduce unforeseen difficulties. 3. Educational impact beyond science.
the narrative around Mars exploration often focuses on scientific discoveries such as evidence of ancient water, but the educational outreach component, particularly through programs like Rover Goes to Mars, demonstrates that inspiring and engaging young students can have a profound impact on the future of space exploration. This underscores the idea that the success of scientific missions is not only measured by discoveries but also by their ability to cultivate a new generation of scientists and engineers. For unexpected discoveries in expected locations, each rover was sent to locations presumed to have been conducive to past life based on prior geological understanding. However, discoveries like Opportunity finding ancient water indicators in areas that were not initially considered prime candidates for such features demonstrate that our preconceived notions about where to find evidence of life on Mars can be misleading. This serves as a reminder that exploration can yield surprises and assumptions about environments can be proven wrong. 5. Technological evolution versus human ingenuity. While the evolution of rovers shows a clear trajectory of technological advancement from Sojourner to Perseverance, the success of earlier missions relied heavily on human ingenuity in problem-solving and adaptability in the face of challenges. For instance, when Spirit faced mechanical issues, engineers adapted their approach to maximize its scientific output despite its limitations. This suggests that human creativity and flexibility can be just as important, if not more so, than technological advancements in achieving mission objectives. 6. The role of international collaboration. The narrative around Mars exploration has typically emphasized NASA's dominance, but the introduction of China's Zhurong rover illustrates the growing diversity of contributions in this field. This counters the expectation that only one nation can lead in space exploration, highlighting that collaborative efforts and international competition can drive further advancements in understanding Mars and potentially other celestial bodies. 7. The unexpected impact of failure. The twin rovers Spirit and Opportunity were born from prior failures in NASA's missions, which could have led to a more cautious approach to Mars exploration. Instead, these failures prompted a more ambitious and resilient strategy that led to significant scientific breakthroughs. This challenges the common view that failure is purely detrimental and instead suggests that it can serve as a catalyst for innovation and success. 8. Public engagement as a scientific tool. The Rover Goes to Mars program not only engaged students but also served as a vehicle for scientific outreach, demonstrating that public engagement can enhance scientific missions rather than be seen as ancillary. This perspective shifts the focus from viewing public engagement as merely a PR effort to recognizing it as an integral part of the scientific process. 9. The significance of geological context. The findings of the rovers have often been framed in terms of direct implications for the search for life. However, the geological context, like the discovery of ancient hot springs or sedimentary layers, has been equally important. This counterintuitive understanding emphasizes that the quest for life on Mars is as much about understanding the planet's geological history as it is about searching for biosignatures. 10. Cultural and historical significance. The naming of the rovers, particularly through student participation, reflects a cultural significance that transcends scientific achievement. The involvement of young people in naming missions and shaping their narratives indicates that the human story behind these machines is as vital as the scientific knowledge they impart. This challenges the notion that scientific endeavors are purely technical and highlights their broader societal and cultural implications. The report on Mars rovers highlights significant milestones in space exploration that are often overshadowed by the more popular narratives of technological achievement and scientific discovery. Here are some overlooked yet significant content elements, along with their implications. 1. Long-term durability and mission extensions. While the report mentions that Spirit and Opportunity were designed for 90-day missions but lasted for years, the implications of this durability are profound. The extended lifespans of these rovers demonstrate not only the robustness of the technology but also the potential for cost-effective exploration. Each additional day of operational success meant more data collected without the need for new missions.
This endurance reflects not just engineering prowess but also a shift in how we approach interplanetary exploration by maximizing the return on investment from each mission. 2. Discovery of ancient water and its implications.
The confirmation of Mars's wetter past by rovers like Spirit and Opportunity is often highlighted, however.
The significance of these findings is sometimes understated.
The evidence of ancient water environments fundamentally changes our understanding of Mars as a potential cradle for life. This raises important questions about the habitability of other celestial bodies and the conditions that support life across the universe. The geological findings provide a framework for future missions aimed at searching for microbial life not just on Mars but on icy moons and exoplanets as well. 3. Educational outreach and its impact. The report discusses the Rover Goes to Mars program, which engaged students in the missions. The long-term impact of such educational initiatives is significant. They foster interest in STEM fields among young people and help create a pipeline of future scientists and engineers. This grassroots engagement is crucial for the sustainability of space exploration as it generates public interest and investment in science. The personal stories of individuals like Abigail Freeman and Courtney Dressing illustrate how early involvement in missions can shape career trajectories and inspire a new generation of explorers. 4. International collaboration and competition. The mention of China's Zhurong rover introduces the concept of international collaboration and competition in space exploration. While NASA has led Mars exploration, the entry of other nations into this domain signifies a new era of space exploration that could lead to collaborative missions or healthy competition. The insights gained from diverse approaches to Mars exploration could enhance our understanding of the planet and expand the scope of future missions. 5. Technological evolution of rovers. The evolution from Sojourner to Perseverance illustrates significant advancements in robotic technology, particularly in terms of autonomy and mobility. The ability of modern rovers to navigate and make decisions independently reduces the reliance on Earth-based control, allowing for more extensive exploration and data collection. This evolution is not just a testament to engineering advancements but also a strategic shift in how we explore distant worlds, making it feasible to study parts of Mars that would have been inaccessible in earlier missions. 6. Cultural and philosophical reflections. The report touches on the cultural importance of Mars exploration, emphasizing humanity's desire to explore the unknown. The personal anecdotes from scientists and engineers reveal the emotional and philosophical connections individuals have with these missions. This aspect often gets lost in the technical details but is crucial for understanding why space exploration matters to society. It speaks to our inherent curiosity, the quest for knowledge, and the drive to extend our presence beyond Earth. 7. The role of failure in learning. The challenges faced by rovers such as Spirit's immobilization in a sand pit and Opportunity's demise during a dust storm are critical learning points. These failures highlight the unpredictable nature of space exploration and the need for adaptability. They remind us that each mission is not just about successes but also about the lessons learned through adversity. This resilience is a vital aspect of scientific inquiry and technological advancement. 8. Future missions and sample return goals. The focus on Perseverance's mission to collect samples for future return is significant as it represents a pivotal step in space exploration. The ability to bring Martian materials back to Earth for detailed analysis could revolutionize our understanding of the planet's geology and potential for life. This goal underscores the importance of planning for long-term scientific objectives rather than short-term explorations. In conclusion, the report on Mars rovers encompasses a wide array of themes that extend beyond mere technological achievements. The interwoven narratives of human curiosity, educational outreach, international collaboration, and the philosophical implications of our explorations are crucial for appreciating the breadth of impact that these missions have on our understanding of Mars and the broader universe. Recognizing these dimensions can inspire future generations to continue the quest for knowledge and exploration beyond our home planet.
1. Transformational discoveries of Mars rovers. The Mars rovers have fundamentally altered our understanding of the planet.
The twin rovers Spirit and Opportunity provided definitive evidence of past liquid water on Mars, confirming that it once had conditions suitable for life. This discovery, along with Spirit's findings of mineral formations and Opportunity's identification of hematite blueberries, reshaped planetary science and led to the development of larger, more advanced rovers like Curiosity and Perseverance. The latter two have continued this legacy by discovering ancient riverbeds, organic molecules, and collecting samples for future return missions. The impact of these discoveries is profound, influencing not just scientific discourse but also public interest in space exploration. 2. Technological evolution in rover autonomy. The advancements in rover technology over the past 2 decades illustrate a trajectory of increasing complexity and capability. Starting with Sojourner, which was limited in mobility and required constant communication with Earth, the evolution to Spirit, Opportunity, Curiosity, and Perseverance showcases enhancements in design, autonomy, mobility, and scientific instrumentation. Curiosity and Perseverance in particular are equipped with advanced autonomous navigation systems that allow them to make real-time decisions, significantly increasing the scope and efficiency of their missions. This technological evolution not only improves scientific outcomes but also sets the stage for future missions, including potential human exploration of Mars. 3. Impact on science education and public engagement. The Mars rover missions have served as a powerful tool for education and inspiration, particularly through initiatives like the Rover Goes to Mars program. This initiative engaged students globally, fostering a new generation of scientists and engineers. Participants in the program, such as Abigail Freeman and Courtney Dressing, credit their involvement with shaping their careers in planetary science. The emphasis on outreach and mentorship highlights the importance of making space exploration accessible and exciting to young people, thereby ensuring a diverse and inclusive future for science and technology fields. 4. International collaboration and competition in Mars exploration. The Mars exploration landscape has expanded to include international efforts such as China's Zhurong rover, marking a significant development in global space exploration. This collaboration and competition among nations not only enhance scientific understanding of Mars but also create a shared human endeavor in the quest for knowledge beyond Earth. The inclusion of international missions encourages a broader perspective on planetary science and promotes cooperative efforts in future exploration, potentially leading to shared discoveries and advancements in technology and science. Famous historical cases similar to Mars rover exploration. 1. The Apollo moon landings 1969 to 1972. The Apollo program represents one of humanity's most significant achievements in space exploration. Aimed at landing humans on the moon and safely returning them to Earth, Apollo 11 successfully landed astronauts Neil Armstrong and Buzz Aldrin on the lunar surface on July 20, 1969. This mission marked the first time humans set foot on another celestial body, achieving a goal set by President John F. Kennedy in 1961. The subsequent Apollo missions further explored the moon, collecting samples, conducting experiments, and expanding our understanding of lunar geology. The technological advancements and international collaboration during the Apollo program laid the groundwork for future space exploration initiatives, much like the Mars rover missions have done for planetary science. 2. Voyager program 1977-present. Launched in 1977, the Voyager spacecraft were designed to explore the outer planets of our solar system. Voyager 1 and Voyager 2 provided unprecedented data about Jupiter, Saturn, Uranus, and Neptune, including detailed images and information about their moons and rings. Voyager 1, now in interstellar space, has made significant contributions to our understanding of the heliosphere and cosmic rays. The program has also sparked public interest in space exploration, inspiring generations to consider careers in science and engineering, similar to the Mars rovers.
The Voyager mission showcased the capabilities of robotic explorers in conducting complex scientific investigations far from Earth. 3. Hubble Space Telescope 1990-present. The launch of the Hubble Space Telescope marked a new era in astronomy and space science.
Hubble's ability to capture high-resolution images and collect data across various wavelengths has revolutionized our understanding of the universe, from the formation of stars and galaxies to the expansion rate of the universe itself. The telescope has provided insights that have fundamentally altered scientific theories and engaged the public's imagination in the wonders of the cosmos. Just as the Mars rovers have provided groundbreaking discoveries about Mars, Hubble has opened new windows into the vastness of space, emphasizing the importance of long-term investment in scientific exploration and technology development. These historical cases demonstrate the enduring human quest for exploration and understanding. Echoing the milestones achieved by Mars rovers in expanding our knowledge of planetary environments. Future outlook: exploring the red planet, Mars rovers and their impact on space exploration. As we reflect on the past 2 decades of Mars rover missions, the future of Martian exploration is bright. The legacy of rovers like Sojourner, Spirit, Opportunity, Curiosity and Perseverance has not only expanded our scientific knowledge of Mars but has also paved the way for ambitious future missions. Here are some predictions and insights into what we might expect in the coming years. 1. Advancements in rover technology. Future Mars rovers will likely incorporate even more advanced technologies, including enhanced artificial intelligence (AI) for autonomous navigation and decision-making. This will allow rovers to operate with minimal human intervention, increasing the efficiency of exploration missions. Rovers could be equipped with more sophisticated scientific instruments, enabling them to perform complex analyses on-site and transmit data back to Earth in real time. 2. Sample return missions. NASA's Perseverance rover is already collecting samples for a future return mission to Earth. The Mars Sample Return Campaign, a collaborative effort between NASA and the European Space Agency (ESA), aims to bring Martian soil and rock samples back to Earth by the late 2020s or early 2030s. This will provide scientists with unprecedented opportunities to study Martian materials in detail, potentially uncovering signs of ancient life. 3. International collaboration. As demonstrated by China's Zhurong rover and the upcoming European Space Agency's ExoMars mission, international collaboration in Mars exploration is becoming increasingly important. We can expect more joint missions that leverage the strengths of multiple space agencies, fostering a global approach to understanding Mars. These collaborations could lead to shared technology, data, and resources, enhancing the scientific return of missions. 4. Robotic and human missions. The exploration of Mars is expected to transition from robotic to human missions in the coming decades. NASA's Artemis program aims to return humans to the Moon, serving as a stepping stone for future manned missions to Mars. Expected to occur in the 2030s, these missions will utilize insights gained from rovers and robotic landers to ensure the safety and success of human explorers on the Martian surface. 5. In situ resource utilization (ISRU). Future missions will likely focus on ISRU technologies, which allow astronauts to produce fuel, water, and other essential resources from Martian materials. This capability will be crucial for sustaining long-term human presence on Mars and reducing the amount of supplies that need to be sent from Earth. Rovers equipped with ISRU technologies could test and optimize these processes in advance of human missions. 6. Increased public engagement and education. The success of programs like Rover Goes to Mars has shown the importance of engaging the public and inspiring the next generation of scientists. Future missions will likely continue to prioritize outreach and education, utilizing social media, interactive platforms, and virtual reality experiences to share the excitement of Mars exploration. Programs aimed at diverse student populations will help cultivate a new wave of scientists and engineers. 7. Interplanetary robotics.
As we develop more advanced robotic technologies, we may see the introduction of multi-robot systems capable of cooperating on Mars. These could include rovers, drones like Ingenuity, and stationary landers working in unison. Such systems could vastly improve our understanding of the Martian environment and allow for more comprehensive data collection. 8. Exploration of Martian moons. Future missions may expand beyond Mars itself to explore its moons Phobos and Deimos. These bodies may hold valuable insights into the history of Mars and the solar system. There are discussions about potential missions aimed at landing on and exploring these moons, which could serve as staging points for Mars exploration. 9. Climate and atmospheric studies. Understanding Mars' climate and atmospheric conditions is crucial for future missions. As rovers continue to study the Martian environment, we can expect more sophisticated atmospheric monitoring instruments to be deployed. This data will be vital for preparing for human missions and understanding how to protect future explorers from radiation and other environmental hazards. 10. A broader search for life. The ongoing quest for signs of life on Mars will gain momentum with future missions. Enhanced scientific instruments and sample return missions will allow for a more detailed analysis of Martian geology and chemistry. The search for biosignatures, indicators of past or present life, will remain a driving force in Mars exploration, with the potential to reshape our understanding of life's existence in the universe. Conclusion. The next 2 decades of Mars exploration promise to be transformative, driven by technological advancements and international collaboration. As we build on the successes of past missions, our understanding of Mars will continue to deepen, laying the groundwork for human exploration and the search for extraterrestrial life. The legacy of Mars rovers will inspire future generations to pursue careers in science and engineering, ensuring that the spirit of exploration continues to thrive.